Hello. So today we're going to talk about uh, kind of like a preface of RC circuit. So R means resistor, and C means capacitor. Okay. So we want to talk about an exponential function. So this should be in the math, but I want to do a review here. Exponential function. So exponential function, let's say E is a function of t, right? That's exponential function. So let's plot it, okay? So E is equal to 2.718, right, in value. So T, I'm gonna try the T is equal to 1, 2, 3, okay? So I'm gonna plot that. So I give the value first, ET and T. So when T equal to 0, then this is E0, right? So E0, which is equal to 1. Okay, so this is equal to 1. Okay, I'm just going to compute the value of this. So this is also ET. Okay, and then when T equal to 1, then this is E1, right? So that's E1. So E1 is equal to 2.718 to the power of 1. So that's still 2.718. Okay, so that's 2.718. And 2, so E2. You may be wondering why we're doing this, okay? But there are a lot of students, it's not familiar with this, so that's why I'm doing this. So E2 is equal to 2.718 squared, right? And that's equal to 7.389. Right, so really I want to make this one 7.189, okay? So 7.389, okay? And now E3, right? So E3. So I want you to see that, you know, what does the graph look like? So this is equal to 20, okay? Hopefully you trust me already. So E3 will be 2.718 to 3, and that's equal to about 20, okay? All right, so now I want to plot this, okay? So I'm going to change in color here. Okay, I want to make it like that. So you can see when I go from 3, this guy already go to 20, right? So from T, from 0 to 3, and this ET already go from 1 to 20, okay? So that's why I'm doing a graph like that. So this is T, and this is 1, 2, 3, okay? And that's 3, so if I make this one, I guess 3 there, 3, somewhere here is 3, right? So that's 3, and that will be 6, and that will be 9. Oh, see, it's out of it, right? So 12, so it's more, okay? So 15, so 20 is out of page. So you can see 1 is equal to 2.718, so roughly there. So that's my first point. So 1 and 2.718, okay? So this is my ET here, and this is my T, okay? And 2 will be 7.3379, so 7. So I'm going to pick somewhere about here, right? And 3 will be 20, so it's out of page already, okay? So it's right there, yeah, like somewhere there. You can see this function goes like this, right? So when it's equal to 0, is equal to 1, okay? So it's equal to 1 there, right? 0 is equal to 1, right? So it's there. So this guy goes like that. Okay? So you can see this, that's why there's a E exponential function is also called exponential growth. So if you can investment, right? If you do investment and you can achieve exponential growth, with the right kind of E, right? you're very happy, okay? So in 3 years, you already grow 20 times. Well, that's, even Warren Buffett cannot do that. Okay, so that's ET, okay? Now I want to show you the E negative T, okay? Well, this is mass, right? So E negative T, so then when T, E negative T, and so just draw this now, right? So this is T, right? So E negative T really is just equal to 1 over ET, okay? And this is just for mass. So basically, this is 0, then it will be E0. So that's still equal to 1, right? And then when T equal to 1, then this is E negative 1, right? So E negative 1, I computed. E negative 1 is equal to 1 over E1, which is equal to 1 over 2.71a, which is equal to, it's a little more than 0.3, right? So 0.368, okay? So this is 0.368, all right? So then 2 is E minus 2, so it will be E minus 2 is equal to 1 over E2, which is 1 over 2.718 squared, and that's going to be equal to 0.135, okay? So 0.135. So I need one more point, and then we can do our plotting. So E minus 3, and that's equal to 0.05, okay? You can see, remember this was 20, right? So 20, so 1 over 20 is equal to 0.05, okay? So hopefully you can trust me. So now let's plot this graph here. So what does it look like? I know when it's 0 go to 3, but this guy only go from 1 to 0.05, okay? So this is smaller, right? So I'm going to do this here. I'm going to call this one 1 here. 1. And then, okay, so that's 1, 2, oops, 3, okay? All right, so 1 or T equal to 0, right? And T, this is T, and this is E minus T, okay? So T, when T equal to 0, is this one here, so it's equal to 1. So I got this point here, that's first point. And T equal to 1 is this one here, so T negative 1 is 0.368, so it's right there. Some of you may be getting boring here, but some student, a lot of students actually. So E equal to 2, now I got 0.135, right? So 0.135, very low there. And then 0.05, ooh, it's almost right there, right? So you can see now this curve looks like this. Okay? And this is called exponential decay, okay? Right? So you go from 1, and in the time of 3, you already decay by how much? You decay by from here to here. You decay by 20 times. See that? You decay 20 times. 20 times. So if that's your investment, then you have 1 million, and after 3 years, you only have 1 million divided by 20, which is only 50,000, right? So 1 million become 50,000, right? So 1 10 to the 6. So only this much left. So that's not too good, right? So this is called exponential decay. So you decay very fast, okay? Well, that's terrible. Okay, so that's the preface of what we want to talk about. But in RC circuit, we care about transient, okay? So from T equal to 0 to T equal to almost infinity, okay? We don't care about the steady state as much. So steady state, right? It's like after, a long time, okay? Basically after a long time. So T is larger than, a big number, right? So I mean, you can say P is larger than infinity, but larger than infinity is like, that's too big, okay? We don't know what's T is larger than infinity, but after a long time is how we describe it. So you can see in the RC circuit, you have this, and then you have a resistor, and then here comes a capacitor, okay? And you have R, you have a C. And in the beginning, there's no charge, right? No charge. Okay. And you have a plus, minus, you got the, usually we call that epsilon sometimes. Okay. Epsilon is the battery's voltage difference. So this is batteries, right? Electric potential difference. Potential difference. Okay, between two terminal. Okay, so this is epsilon. We don't call that V because there's too many V. So sometimes we're using epsilon. It's called EPSILON. So please practice that epsilon like that. All right. So when this first connected, there's no charge. So then the electron will start moving. Okay, the electron will be going from here, right? The electron will be going from here. The electron is initially inside the atom. So you move and go, and then start it and put one electron there. So you got one electron here, you got plus there, okay? So that's what happened. So then basically that is the current. So there is a current going on in the beginning. And finally, after a long time, then it stopped because this is all populated already, right? All populated already. Then, okay, then there's no current. Then in the end, current will be zero, right? In the beginning. So after a long time, current will become zero. But in the beginning, right, at t equal to zero, there's an I, okay? I is larger than zero, it's significant. And start, moving the electron, all right? Okay, we're gonna stop there and we're gonna continue later, all right? Hopefully you get to understand a little bit of RC circuit and why we care about transient.